principal problem. You ready? So look at 40. It talks about ice, block of ice, let's say, or some kind of ice, floating in the water, and there's a polar bear on top. That's the best I can do. All right, so
I didn't know polar bears.
let's write down everything we know about the problem. So what's been given?
Density of ice, density of seawater.
What's the density of ice?
917 kilograms per meter.
Meter cubed.
Oh, yeah.
And the density of salt water, the 1025?
Yeah.
Yes?
Yeah.
What else do we know? We know one more piece of information.
Floating ice.
Volume of the ice.
5.2.
5.2. All right. So the problem says, what's the weight of the bear or something like that? Ultimately,
What's the heaviest?
what's the heaviest the bear can be without the ice sinking below the water? So what that means is the surface of the ice would be just at the surface of the water. Does that seem reasonable if we think about the problem statement? The top of the ice is just right level with the water. Are you guys okay with that idea? So let's think about the forces here on this system. There are two obvious ones.
Gravity. Mass of gravity.
Forces.
Support.
Force of gravity on what? And
Ice.
the ice. Isn't there gravity pulling down on the ice and on the bear?
Yes.
Okay, so I have mass of ice times g down. Do you agree? I also have mass of bear times g down. But something is keeping it afloat, the whole system. So what is that force? The buoyant force, okay? So we've got the buoyant force. So there are three forces in this problem. Two of them are weight. The third one is up, and it is buoyant force. Question?
Maybe repeat the question. But so you the weight.
Okay, I've got weight of these two things down, and something is keeping them afloat. That's the buoyant force. So FB minus mass of the bear times G minus mass of the ice times G equal 0 if they're floating. Does that seem reasonable? They're balanced forces. It's not like a beach ball. If I hold a beach ball underwater and I hold it there, the forces are balanced. As soon as I let go, all you have really is buoyant force because it's so light that it will accelerate upward. Right now, these things are not accelerating, just sitting there floating. Now, this, remember, is the definition of buoyant force. So what fluid are we referring to being pushed aside?
Water.
What kind of water? Seawater. So if I want to write this force like this, I need to make sure I get rho of salt water. What's the object I'm talking about here? Just the ice. The bear is not in the water. If part of the bear was in the water, that part of him would be displacing some water also. It's just the ice. So it's the volume of the ice times G. Minus the mass of the bear times G minus, how do I get the mass of the ice?
The density,
Yeah, you done volume.
I have density of ice.
multiplied by
Do I have volume of ice? So if I take density of ice times the volume of the ice, that gives me the mass of the ice. This is why I want to do this problem, because it shows you a lot of technique. Okay? Times G equals 0. You guys tracking? Crack-a-lackin'? Alright, so what's the ultimate question? How much does the bear weigh or something like that? What's the weight of the heaviest bear? So ultimately we have to solve for the bear's weight here in this problem. You guys okay so far? Any questions? Taylor, you alright?
Yeah, we're good.
Poker face. Go! A question!
So by setting it equal to 0, is that how you are able to find the heaviest to like change it from being?
Right, so that means the weight of the bear and the ice and the buoyant force are exactly going here. Do I know this? Do I know this? I can actually cancel G every, oh no, I don't want to do that.
Yeah.
Why don't I want to do that?
Because you want to find
I want to solve for the weight of the bear. So I'm just going to go ahead and write this out. This is the weight of the bear equals rho salt water volume ice times G minus rho ice volume ice times G. So when you calculate this value, that will give you the weight of the bear. So go ahead and plug that in, and let's see what you guys, yeah, I agree. Yes?
Yep.
Are there questions about this? I'm going to give you one to work on your own next. But any questions about what goes on here? Go.
Where did we get the volume of ice?
It was given in the problem.